Hello guys, welcome back to Maths on African Motives, still on mathematics and 5, working on our integrals, working on integration. This time we are going to be focusing with another type of integration, which is the chain rule for powers of f of x, which we might be wondering to say the chain rule, what is the chain rule actually applying? In integration, we only think about the chain rule when we have it in our derivatives there. All right, we have another special type of integral that applies this chain rule concept, which states that if you are given the integral of, in this case, f of x, let's say we have got our f of x being raised to the exponent of n. So we've got our f of x raised to the exponent of f of x multiplied to its first derivative with respect to x. All right, this is supposed to be equal to f of x to the exponent of, take note, we are going to integrate this, which is n plus 1 over n plus 1. That is the whole part that we just need to know, plus the constant of integration. That's it. That's it. That's the only part that you need to know. But this only part, it has a lot of things to deal with. Okay, which things are we talking about? We are supposed to see that this is our original function. This f of x is representing the original function that you are given. This is what you are referring as your original function according to what you're given. Then if we check here, we've got its derivative. So this must be the derivative. It's corresponding what? It's corresponding derivative in this case. So the most part is that they are not going to give you mostly a derivative. They are not going to give you a condition where it is direct. You see the f of x, you see the corresponding f of x, like that corresponding. No. It's not going to be like that. They will try to play around with you guys. But let me bring this question into our consideration so that we can try to apply this concept. Let's say we are given a trig function. For an example here, we're given a trig function like to integrate sine of x. We have given the sine of x, this whole part of sine of x in this case. All right, so let me bring it this way so that we can understand. So we are given the sine of x, this whole part here, being raised to the exponent of 3. All right, multiplied to cosine of x like this with respect to x. All right, so the question is, we are having an exponent here, okay? We are having an exponent, which is fine. But is it considering that this f of x is giving us f prime x, which is the first derivative of x? All right, let us consider our f of x. Our f of x in this case is representing the sine of x. And from our derivative, what is the derivative of sine of x? The derivative of sine of x is equivalent to cosine of x. So this is truly corresponding. This is f of x. This is our f prime x. Whenever this is giving us this part, guys, the law is, or the rule is stating that our answer is going to be f of x to the exponent of n plus 1, meaning to say you consider your f of x in this case, which is what? Which is sine x. So we are going to have the sine of x in this case. This whole part of sine of x having an exponent n. Our n in this case is 3, but we are having n plus 1. So this is going to be 3 plus 1, which is a 4. So we are going to obtain 4 over n plus 1, which is the same exponent that we have here, is the one that you're going to use here, plus the constant of integration. That's it. That's the whole idea of this question, guys. That's the whole idea of this question that we are given. But we know that if we are given sine x to the exponent of 4, like we are given sine x like this to the exponent of n, it simply means sine to the exponent of nx. So meaning to say, here we can just write this as sine to the exponent of 4x, everything over 4, plus the constant of integration, which is 1 and the same thing, or you can just leave your answer like that. All right, guys, this is not enough. This is not enough. I want to bring another question into consideration. I don't want to remove our formula so that we properly understand the concept. So I'm not gonna take down this formula. I want this formula here. All right, so let me just try to bring this one up or another side. Let's hope I'm going to win. I just want to bring this one another side or even up here. It's fine so that we do not confuse this part with our calculations. All right, so sorry for this, guys. Sorry for that. All right, so I want this formula mostly. So I want to keep this formula. All right, now we are all right, I want to keep this formula. Now we are given this one, the integral of x, all right, which is into 3x squared plus 2 like this to the exponent of 4 with respect to x. This is what we have. All right, thinking of this formula, how is it going to work, this part? How is it going to work? Our first part is supposed to be f of x raised to the exponent of n. We can see here there's an exponent of n, then the derivative. So let us try to just rearrange so that we can see properly. This is 3x squared plus 2 like this to the exponent of 4 times x with respect to x. Remember, the product of a and b is the same as the product of b and a. It's just one and the same thing. Now let us analyze from this. We want to analyze this concept because we are saying this is our f of x, this one. This is our f of x. So you work with f of x, and this is our exponent, which is n. This f of x is it giving us the first derivative. Okay, let's take it down. Our f of x is equal to 3x squared plus 2 like this. This is our f of x. Its derivative is supposed to be what? It is supposed to be 3 times this, which is 2 times 3, which is 6x. Then the derivative of 2, that's a 0. This was supposed to be the derivative of this f of x, but here we are not having 6x. This is not x. We are not having the part that is given here. Our part here is x, but we are supposed to have this because this represents f of x. So our f of x here is supposed to be 6x. So we are supposed to have 6x like this. But how can we have 6x? We don't just write 6x inside. All right, you are going to multiply by 6 over 6 so that this number becomes a 6. You are going to multiply by 6 over 6. Multiplying by 6 over 6 simply means you are multiplying by 1. 6 into 6, that is a 1. So multiplying by 1 does not affect our part, as we want this 6 to multiply here, to multiply this x. So meaning to say, if we remove this 6 to multiply x, here we are going to remain with 1 over 6. We have removed this 6, so we are going to remain with 1 over 6 into the integral of 3x squared plus 2 to the exponent of 4 times. Now this 6 multiplies this x, so it is going to be 6x like this. Now it makes sense because our f of x is giving us the first derivative, which is 6x, and this is what we have, which is 6x. Once this can be written in a way that your f of x gives you f prime x like this, raised to a certain exponent n, therefore we can apply our rule, or we can apply our concept, which states that our answer is going to be f of x to the exponent of n plus 1, whereby we've got 1 over 6 into our f of x, which is this part. So it's going to be 3x squared plus 2. That's our f of x to the exponent of n plus 1. So if we add 1 on our exponent here, that's 5 plus 1. 4 plus 1, which is going to be a 5 over n plus 1 is the same exponent that you had. So meaning to say we are going to have 5. That is it, guys, plus the constant of integration. This 6 is no longer useful because it is the first derivative of this. Once this gives us the first derivative, you use the rule. That's it. All right, so this at the end, we are going to multiply the numerator to the numerator. That's 1 times this bracket. We are going to have our bracket of 3x squared plus 2 to the exponent of 5, everything over 6 by 5, which is going to give us a 30 in this case. All right, plus the constant of integration, or you can write it as 1 over 30 into that bracket, which is one and the same concept. All right, so that's how they ask these typical questions, guys. You have to be just careful on how to attempt it, knowing your first derivative and your f of x from the original f of x, it must give us the first derivative. If not, try to make them to be the same. All right, let us have another question into consideration still on this application. Let's say we are given to integrate sine of 3x. We've got sine of 3x over, in this case, the square root of 2 plus cos 3x. All right, 2 plus the cosine of 3x with respect to x. We can think of many integrals that we can use in this case, but it's actually difficult for us. If we are to take this into f of x to the exponent of n, it means, let us start with the square root of, remember the square root simply means to the exponent of a half. X to the exponent of a half means the square root of x. But since this is in the denominator, once you take it up, it is going to carry a negative exponent there. So it is going to be the integral of 2 plus the cosine of 3x to the exponent of negative half. This is the one that made us 1 over 2 plus cos 3x, and we introduce the square root for the half. All right. Multiplying already on top, we are having the sine of what? The sine of 3x. What is important is to start the one with an exponent here so that we don't confuse f of x to the exponent of n. That's why I had to start with this bracket. Now this is our f of x here. This is your f of x being raised to a certain exponent, but we are not sure about this part. Is it the first derivative of this f of x? So we have to test this aside. All right, our f of x is equal to what? It is equal to 2 plus the cosine of 3x. Let us find the first derivative of this. 2 gives us a 0. That's a constant. Remember, cos, you multiply this number to this part, which is going to be negative 3 sine of 3x. Cos changes to a negative sign. There, we are not having minus 3. If we check here, there's a minus 3. But on our answer here, there is no minus 3. This is the sine 3x. So this one is not the first derivative. So it must be sine 3x. I mean, we are having sine 3x, but it must be negative 3 sine x. So what do? We affect with this part. What we do not have is negative 3. So to obtain negative 3 here, we are simply going to multiply by negative 3 over 3. That's it. That's the whole concept, guys, here. So this one, like I said, we are going to multiply by what we want to have here, which is negative 3 over negative 3. By multiplying by negative 3 over 3, we are simply multiplying by 1, meaning to say it hasn't affected our answer. So this negative 3 is the one that we want to take here inside the sine of x here, so that it gives us negative 3 sine 3x, which is the first derivative as for this concept. All right, so meaning to say we are going to remain with 1 over minus 3, of which 1 over minus 3 is same as minus 1 over 3. All right, the integral of, we write as it is 2 plus the cosine of 3x to the exponent of minus half times, now the minus 3 that we removed here is going to multiply this side. So it is going to be negative 3 sine of 3x like this dx. All right. Having this, we can properly say, okay, this is the condition that we were having here, but it was just hidden because of this part, because here we can see that we have f of x and its derivative, which is the same condition here. This is our f of x here. Its derivative is minus 3 sine 3x, which is the same here. Our first derivative is minus 3 sine 3x. So meaning to say this is our f of x. This is the first derivative. This is our n. So our answer is saying that we are supposed to use the concept now to say whatever that you're going to have here is going to be what? F of x to the exponent of n plus 1. Our f of x, this one, to the exponent of n plus 1, we add 1 here. So that's minus half plus a 1. So if we add a 1, we are going to obtain a half. So that's 2 plus the cosine of 3x, everything to the exponent of a half, if we add a 1 in this case. So that's it, guys, over n plus 1. So this whole part here, let me divide this over n plus 1. Our n plus 1 is the half that we got here. So we're going to divide by what? By a half in this case. All right. So these brackets, they are supposed to be covering everything. All right. This part is supposed to cover everything like this. All right. So this is what we are going to have plus our constant of integration. That is what we have here. F of x, that is the answer to the exponent of n plus 1 over n plus 1. As long this integral is written like this, that f of x here gives you f prime x. It will be raised to a certain exponent. That's how we can apply this. But we can simplify further our final answer here. That will be, if we divide on our calculator, it's 1 divided to this half here. Take note, it's 1 divided to this half, which is going to give us a 2. So it will be negative a third into 2 into 2 plus the cosine of 3x to the exponent of a half like this. All right. So plus the constant. So take note, 1 divided by this half is the one that gave us this 2 that we see here. All right. But on our calculator, again, if we are to multiply, we can combine minus a third times 2, because this is same as 2 over 1. So it is going to be minus 2 over 3 into 2 plus the cosine of 3x to the exponent of a half plus c. So that's it. Or we can write this under the square root. Remember, to the exponent of a half means the square root of. So we can have this as minus 2 over 3, the square root of everything, which is 2 plus the cosine of 3x in this case plus the constant of integration. So here, these 3 you can just put in brackets if you want, but I can even leave it like that. All right, so that was how we're supposed to obtain our exact solution from this concept. So they play around with this idea. So I just hope we understand how to apply this idea, how to use this concept as we are given our questions in this case. All right, so let us check another question. I'm gonna check another question here. Let me just try and remove this part so that we can check another question. All right, so that's it. Okay, all right. So I'm just gonna have another question here so that you can see again how to apply the same concept or the same rule in this case. All right, so let us say this time we are given the integral of e to the exponent of 3x, everything over the square root of e to the exponent of 3x minus 1 with respect to x. We are asked to integrate, all right, using the same concept. So as you can see, we are back to the same way that we had previously, where we are given a square root in the denominator. We take it up, having a negative exponent. So it is going to be e to the exponent of 3x minus 1 to the exponent of minus half in this case, all right, multiplied to e to the exponent of 3x, which was already in the numerator with respect to x. So let us check if our f of x, because this is our f of x here, and we've got and our exponent, which is n. But we want to check, is this our f prime x? All right, so we are going to check aside. F of x is equal to what? That's e to the exponent of 3x minus 1. We find the derivative of e. Remember, e to the exponent of ax. We are going to drop this exponent to multiply. So it's going to be 3e to the exponent of 3x. 1 gives us a 0. So this is what we're supposed to have on our f prime x. But as we can see, it's not the same. Here there is a e, not 3. It's 3e to the exponent. So what are you going to do to have a 3 here? We are going to multiply by 3 over 3. I think now we are used to this. So multiply by 3 over 3. We take this 3 inside. Like I said, we take this 3 inside, so that this is going to be 1 over 3. So we're going to remain with 1 over 3. The integral of e to the exponent of 3x minus 1, everything to the exponent of minus half, which is our n. Then we take this 3 that I said. So this 3 is now multiplying 3e to the exponent of x like this with respect to x. So now it makes sense. This is your f of x, and its derivative is 3e to the exponent, which is the same as what we see here. This is its derivative. So meaning to say our answer is going to be taken as 1 over. So remember what I said, we are going to have this raised to the exponent of n plus 1, f of x. So it's f of x to the exponent of n plus 1 over n plus 1 plus the, that's it. So our f of x is this one, e to the exponent of 3x minus 1. But to the exponent of n plus 1, so we add 1 on our exponent, which is going to give us a half. So that's a half here over a half again. All right, plus the constant of integration. So remember, like I explained before, here we did this type of equation. 1 divided by a half, we ended up having a 2 here. So we are going to multiply a third times a 2, which is 2 over 3. Then this part remains as it is, 3x e to the exponent of 3x minus 1 to the exponent of a half plus c, which can be taken as the square root of that number that you are given in this case. So this is going to be 2 over 3, the square root of this part, e to the exponent of 3x minus 1 plus the constant of integration in this case. All right, so I think with these questions, we can be able to attempt as much questions as we can. Oh, let me just bring one more last question so that you might catch up if in case you had missed another part. Let us just give another question of a trigonometry again, so that we'll see how to apply this concept here. This time we are given number 5, that is the integral of sec squared. So this is sec squared 2x everything over the square root of 1 plus 5 tan 2x. All right, which is something else here with respect to x. So that is it, guys. We have the square root again. So the square root I explained previously that we are going to take this one up with a negative. So it is going to be 1 plus 5 tan of 2x in this case, everything to the exponent of minus half from 1 over the square root. All right, but multiplying sec squared 2x like this. So we have an f of x, which is this expression here representing our f of x. But is it giving us the first derivative there? That is to check. So we test them, okay? Our f of x is equal to 1 plus 5 tan 2x. What was supposed to be its derivative? The derivative of 1, that's a 0. 5 here, tan, remember we're dealing with tan changes to sec squared, but this 2 is to multiply here, remember, tan ax, the 2 there multiplies, so it is going to be 5 by 2, which is 10 sec squared x from your formula sheet. Also check there, sec squared. All right, so this is sec squared 2x, not 10. Here there is a 10. On our first derivative, we are supposed to obtain a 10. But here we do not have a 10. We are supposed to have a 10. So what are we going to do? All right, just like the previous part, we are going to multiply by 10 over 10. That's it, we are done. So 10 over 10, the integral of 1 plus 5. In actual sense, we are not even supposed to write this 10 over 10. You just have to know that here you multiply by 10, you remain with 1 over 10. All right, but just for the sake of revision, so that all of us, we do understand. All right, so that's it, guys. We are going to take this 10 so that we obtain 10 sec squared. So this 10, we are going to take it to where? To sec squared, remaining with 1. If you remove this 10, we are going to remain with 1 over 10. The integral of 1 plus 5 tan of 2x to the exponent of a negative half like this by, now it's 10 times sec squared. So it's going to be 10 sec squared 2x with respect to x. So having this, we can see, okay, this is our f of x to the exponent of n, and this is its corresponding f of x. This is the corresponding f of x. So we can use now our formula f of x to the exponent of n plus 1. So we are going to have 1 over 10 into f of x, which is 1 plus 5x, 1 plus 5 tan 2x to the exponent of this n. This is our n plus 1. So minus half plus 1 is going to give us a positive half. Everything over a positive half in this case. All right, plus the constant of integral. You're done. So this whole part does not even matter to say what we have here, as long this is your f of x raised to the exponent of n, giving us here the corresponding f prime x, which is its derivative. You are going to use this part. Okay, so that is our chain rule in terms of powers in our integration. You just need to know the concept there. So as we saw, guys, 1 divided to 1 over 2 is going to give us a 2. So that means we're going to multiply 1 over 10 times 2, which is 1 over 5 in this case. So we're going to obtain 1 over 5 in this case into the whole bracket of 1 plus 5 tan of 2x, everything to the exponent of half plus the constant. So that's it, whereby to the exponent of a half simply means the square root of, if you want to write the square root at the end, that will be the square root of 5 tan 2x plus the constant of integration in this case. All right, so this is how we apply the concept check between your f of x and its corresponding first derivative. So if we check like recent question papers from April 2023, August 2023, they were actually working with this type of integral. That is, they want you to understand this part, okay? That is the application of what? Of the chain rule for powers of f of x. They want you to understand this part as much as you can. So we hope as time goes on, we shall have more questions to work on or more revisions to work on pertaining typical questions like this. So for us to know more, let us have the questions also on the comment section so that we can work with them in the next classes that we shall have. But for now, that's it, guys, from Mason African Motives. Till we meet again.